All right, how's it going?
Good.
Let me pass around the sign-in sheet. Well, we had like 37 people in class this morning, so the sign-in sheet is working. So, questions on PA1 or anything up to here? Does PA1 look doable at this point?
At this point, I think I'm ready to submit.
That sounds doable then.
Comfortable.
I feel like I'm having a little bit of trouble. I'm trying to do Java, C for like the fraction test thing.
Mm-hmm.
And it always keeps popping up with like one error. I don't remember what it is. I have to check again.
Can you do it right now and see what it is?
I believe so, yeah.
Because I have a guess.
I just close down a minimum of 10 things. Don't tell me I just cut out.
Yeah, mine just cut out too.
Wow.
Yay, internet.
I'll be glad to play when I get the internet back.
That's why I just used the hardwired connections in the computer labs.
Yeah. Although my hardwire in my office has been glitching lately. All right. Well, let me tell you what I think is probably going on. Remember, if you have a file named blah.java, it's got to define a class named blah. All right. So if you copy pa1 test.java and you try to compile it without changing the name of the class inside, it's going to complain that the class doesn't match.
I grabbed it from within the PDF.
Okay.
And I named the file what the class was.
Okay, so you called it main or something.
Capitalization too.
Okay. Yeah, that should work then.
At least I hope I did.
So
Is
you
it a runtime error? Like,
No, I don't see one. I don't remember seeing the word runtime in there.
Yeah, if it happens when you say Java C, that's compile time. If it happens when you say Java, that's a runtime. But well, when you reproduce it, pop a note on the discussion board, and we'll talk about it. Other questions, issues? Yeah.
The two doubles, should it just return the straight double, or should we kind of cut it off like you have in the example? So like 2/3 would be 0.667?
No, just return the double.
Okay.
So don't truncate it. My example of what you should get is truncated. But yeah, just whatever the division of two doubles gives you, that's what you return. Other questions?
Fraction test. Yep, the class name is correct. And when I try to run it,
Compiled?
Class name fraction test.c only accepted if annotation processing is explicitly requested.
So what did you call the file?
Fraction test.c, and the public class is fraction test.
Okay, so it's got to be .java.
All right.
I did that in the earlier class. I made a stack.c for some reason.
you always compile .java.
Oh, yeah, we're doing Java, not
Yeah.
C. Might help with that. All right. Well, I'm gonna fix those.
Is that Pokemon?
Yeah.
Everything is Pokemon. All right, no network. You got onto the network already?
Yeah,
Okay, I'm not on for some reason.
I think you might have to like reload it or whatever.
All right, let's see. Did I really lose my stack class?
We can build it again.
Yeah, we could, but
We have the technology.
we do have the technology. The only problem is I've done it twice in the past 24 hours. Actually, 3 times because I did it wrong. Oh, you do? Okay. That might help.
You should send it to him in
Wait.
the server message in one.
Yeah, network action. All right.
Stack class.
Here's our stack class. All right, we're back in business. So
That's a lot of it.
So this was our main program we were using to test this. We were creating a stack that could hold 100 things. We pushed some values onto it, and then we had this loop. As long as the stack was not empty, we'd do a pop and we'd print out the value. And the question is, what happens if we actually just print the stack itself? If we just say the value of S is, and we just concatenate S and look at what the stack is.
It would bring an error because there's nothing in the stack.
Well, it could.
It would bring up a random number that existed in the stack.
Or it could give us our annoying stack @ weird hex number, which is the default behavior when you concatenate an object to a string. It creates a string that looks like the name of the class, an @ and then some code that's presumably an internal way of identifying that particular object. So that's not terribly useful. It tells us this is a thing of type stack, but it doesn't tell us anything useful about the contents of the stack. So what if we wanted to be able to do something like this, but have it actually give us some useful information? So for example, suppose we wanted to say S equals a stack containing 4 things, because we pushed 4 things onto it. That might be a little more useful. So how could we change what it prints out when we do this?
Alter the default toString.
Exactly. So when we say plus S, the system is calling S.toString. There is no S.toString inside this class, so it's using a default one, which says return the name of the class, an @ and the hex address of this thing internally. So let's make our own toString method. So toString basically gives us a string representation of our object. So it's got to be public, not olik, public. It's got to return a string, and it's got to be called toString, and it's got to take no arguments. So how can we tell how many things are on our stack?
We could go through a while loop until we get to the array length.
And stack pointer -1.
Or we could do the stack pointer -1. If we go through the array, there's nothing in the array that actually tells us if there's something in that spot that we pushed. And if we use the length, that tells us the largest size a stack can have. But if we want to know how many things are actually on the stack, we have to consult the stack pointer. So if the stack's empty, what's the value of SP? It's 0. And if there's one thing on the stack, what's the value of SP?
1.
So it sounds like SP actually tells us how many things are on the stack. and it was bound to be either SP, SP plus 1, or SP minus 1. It just depends on this convention of what we're taking the stack pointer to mean. In this case, it's where the next thing is pushed. No. Did we die?
I think we did it again.
Okay. We're going to do pencil and paper coding then. Bless you. So we could return this string, a stack containing, concatenate the value of SP and concatenate the word items, and that would tell us how many things are on the stack. We could do this, so if there's only one thing on the stack, it says a stack containing one item, parentheses S, so we don't get accused of not knowing how to use pluralization. But that's a lowball way to do it. We could also do number of items, colon, plus SP. Now it says number of items 0, number of items 1, number of items 2, and we don't have to worry about the plural thing. That's the one I usually cheat with. We could do SP, and we could concatenate the word item, and then we could concatenate the following. We could use this ternary operator and say if SP is equal to 1, concatenate an empty string to the end of item, so it'll just say item. Otherwise, if SP is not equal to 1, concatenate an S to the end of item, so then it'll say items. And that's the excuse for a ternary operator that Kernighan and Ritchie give in their original text on C, and it's still one of the nicer uses of it. So there's a single line way to return a string that says a stack containing some number, item, or items, 1 item, 2 items. But that's all programming details. So we could put that in there, and then when we run our main method and we say print line S equals plus S, it would say S equals a stack containing 3 items. All right, there's a stack class, no comments. I think this is the one we made in the morning class the first day. Okay, so let's make a toString method. What?
It's the one on the shared file.
Oh, okay.
On the website.
I think there's a new one also.
No, I have it open right now. The
But-
one on the shared file.
But I thought I made a second directory like stack2 or something like that.
Oh, yeah. Yeah, I think you did. This one's under stacks.
Yeah.
Stacks 2 is the same thing, but it actually tells you what it does.
Oh, okay. I won't get fancy. All right, so toString just returns a message telling us how many things it has. So we push a couple of things. And we'll print out S. Alright, so S is a stack containing 4 items. And we could do anything we wanted, right? We could say with the capacity of, and we could concatenate the length of the array to tell us how many things we can store. And now S is a stack containing 4 items with a capacity of 5. So when you're designing classes of your own, right, you get to choose all of this stuff. If there's no reason somebody should want to print your object, you don't need to specify a toString. Or you could override toString and have it print out a message saying, like, you know, please use traverse to examine this object, or something like that. And if my toString method takes an argument, what is this going to do when I run my main?
A stack containing object, or whatever it may be, item, or a number, rather, with a capacity of length.
So it's just going to ignore the X?
No, it requires the input.
Oh, yeah.
But for what reason?
What were you starting to say?
It went away.
Oh, okay. So it'll be obvious once we see it. So let's compile this. Let's run it. Stack equals back to our old default toString. Why? Because this is not the default toString signature. This is a different method that happens to be called toString and returns a string, but it takes an integer argument.
So it depends on the constructor.
So it depends on what we call the signature, right? So it's not enough just to have something called toString. It's got to be called toString, and it's got to take no arguments, and it's got to return a string. So technically the signature is a combination of the name and the types of arguments. This is just another random method called toString that takes an integer. It's not the same as toString with no arguments, so we have not overridden that original toString. That's still there. And when we concatenate, in here when we say S equals plus S, it calls the toString method with no arguments. That's the default one. And so we get the boring stack @ sign message. Okay, what if we wanted to use this as a way to show the user everything that's on the stack? So we push a few things, and when we print out the value of the object itself, S, we'd like to see a nice list of all the things on the stack. So let's make a string and start it off as being empty. And let's just go through each element on the stack and just add it to our output value. And when we're done, we're just going to return temp. So temp equals temp plus our array bracket I, and we'll just tack a space on the end. And then we'll return temp. Does that look good? So S equals, and there's the things we pushed in reverse order. So 738 minus 2. Let's make one more fancy thing. Let's put commas instead of spaces. So now we got a comma separated list, but we've got the annoying comma on the end. And there's things we could do to this string to remove the last character. But if the stack's empty, the last character is not going to exist, and we might get exceptions and things like that. How can we avoid adding the comma after the last number?
We can check if the next number is stack pointer.
Yeah. So here's one way to do this. So if I is the stack pointer minus 1, which is the last value that we're going to have when we go through our loop, we'll just concatenate array bracket I. Otherwise, we'll concatenate array bracket I plus a comma. And so there's a nicer list.
I didn't see a print statement, I think, in there.
The print statement is in main, and it's right here.
Ah,
Right? So toString usually does not print anything. toString returns a string, and so this is actually s equals plus s dot toString. So we're calling
so it'd be
toString.
a string from that for loop.
And then we take that and we concatenate it to s equals, and we print it here in main.
Oh.
And we could do this a bunch of different ways, right? We could go ahead and concatenate array bracket I, and then if I is not sp minus 1, concatenate a comma. So we could do it with a single if. We could do it with a ternary operator. Same way we got rid of the s. So lots of different ways to do it. But the punchline here is, right, this is your code. This is your class, right? And this is a method that you're writing in your class to do whatever you feel is appropriate for the toString method or any other methods, right? And it's just code. You know how to write code. You know 224, 121 style code, right? Here we're talking about objects. Last quarter we were talking about data structures. But this kind of thing is just, you know, algorithm implementation. I want to print out 10 things with commas in between them and then go down to a new line so that I don't have stuff scrolling off the end of the screen, right? Or I want everything that I print to have exactly 5 characters with leading zeros and whatever, right? So it's the thing about Java is it tends to be just a lot of programming. Once we understand all the classes and we understand how to work with them, we're really just kind of taking the pieces, the Tinker Toys, and putting them together to build our castle or dragon or whatever, right? And this is fun. Okay, the other thing to notice in here is I keep recompiling stack. I have not recompiled main. Right? Main was compiled 9 minutes ago. Stack I keep recompiling every time I make a change. If I change the toString method of stack.java, I have to recompile so that it takes effect in stack.class. But main was compiled. Main is just this code up here. Nothing in there has changed. When it runs, it's going to access a method in S called toString. But that method is not part of main.class. That's part of stack.class because S is a stack. So stack needed to be recompiled, but this main.class works exactly fine as it is. And that's pretty cool because just by updating the class file for this object, for this class called stack, right, we can use this and always have the latest version. We don't have to recompile main just because it's using this class. Hey, we finally timed out, good. All right, any other questions on that? Okay, let's go on to something you need to hear from me rather than on the street. Because I'm starting to see this in people's code, and so you're going to use this anyway. I want to make sure you understand what it does and why we use it. So let me find a rectangle class. Oh, I got old rectangles. Okay. Wonder what else I have in here. Oh, I got lots of stuff.
Hold on.
What do we got? Oh, look at all that code, man. No.
All of that.
Yeah. All right, hold on a second.
Remember
This is the forbidden code.
Pay no attention. All right. This is safe for work now. So there's a rectangle class. It's got a height and a width. It's got a toString method. We've got a couple of getters for height and width. I'm going to put back the stuff that I deleted, but that's what I want to talk about. We've got a set height and width method that makes sure we don't use negative values or 0 for those. We've got a method for finding the area and a method for finding the perimeter. So that's a nice rectangle class. And so let's simplify our main. So we'll make a 5x7 rectangle. We'll print out the height and the width, the area and the perimeter, and then we'll say r equals and print out r. This looks pretty harmless. But there's no constructor, so that's one of the things I got rid of. So let's make our constructor. So our constructor is going to take 2 arguments. So it's public rect, integer h, integer w. Height equals h, width equals w, and that's the end of the constructor. So we make a 5x7, it's 5x7, area, perimeter, and printing out using the toString. So this is kind of where we were the other day, last time we did rectangles. And I want to look at this constructor. So very straightforward code. We pass 2 arguments, which I'm calling h and w. We set the height to h and the width to w. Okay, so in past classes I've said things like use descriptive variable names. And h and w are not terribly descriptive. I mean, they are here, but if this was a million lines of code, what is h, what is w? So if we really wanted to use descriptive names, here's what we'd like to say. We'd like to call this height, and we'd like to call this width. And now this statement would say something like this. And it won't blow up, but it's kind of silly, because saying height equals height doesn't do anything. It says take the value of height, set height equal to that, and height is a temporary variable because it's an argument. So this will do practically nothing. If I compile it and I run it, my rectangle is 0 by 0. And that's appropriate because, remember, there's a scoping of variables. There's height and width, which are class variables. I should have made these doubles, just to be consistent. There's height and width up here, which are class variables. But when I say the arguments of a method are called height and width, these are local variables to the method. So when I say height equals height, it says take the value of height, that's this argument, and set height equal to it, that's this local variable. It doesn't do anything, but in particular it does not change the value of this class variable. And width equals width doesn't change the value of that. And if I came down here and I said height equals 100, width equals 224, that's still not going to do anything. It's still a 0 by 0 rectangle. Because the word height here refers to this. So the question is, if I have arguments named height and width, how do I get to this height up here? The height that belongs to the object.
We need some kind of identifier.
We need some kind of identifier. Now in our main class, since R is our rectangle, we could do something like R dot height. Right? We can't do it from main because it's private, but that would be the idea. If R is the object, R dot height refers to this variable right here. R dot width refers to this. So inside here, what we'd like to do is something like R dot height, but we don't know that this object is called R, and it's only called R inside main. Could be called R5, in which case this should be R5 dot height. So we need a way to identify this object, whatever this object is. And the way we do that is with a keyword called this. So if we say this dot height equals height, this dot height refers to the class variable named height up here. This dot width refers to the class variable named width. So this is one thing we use the keyword this for. It's a way to refer to ourselves. So whatever this object is, this dot height means this object's field named height. And it gets you outside of the fact that HEIGHT means this argument. Okay, this explicitly says the class variable named height. So there's our 5 by 7. Now we don't need to do this. We could have called our argument height argument and width argument, and then just said height equals height argument, width equals width argument, and all of this goes away. Because height means this and height argument means that, and it's just like using H and W. So this doesn't do anything that we can't do just by slightly changing the names of our variables or putting an underscore in front of them or something. But the conventional way to do this would be to use the actual names of the things that we plan to set as arguments, and then use this, the keyword, to specify the class variables. All right, has that sign-in sheet made it around? So let me pass it around for anybody that got missed. Thanks. All right, so that's one thing we do with the word this. But remember, this is a way to refer to the current object. Okay, it's the ego. It's me, it's I. And we can do this, for example, for constructors. So let's say we want to construct a square. Anybody else need to sign in? All right, cool, thanks. So construct a square. So this is going to be public rect, and we're just going to take one argument side. And we want to make a rectangle with length side, height side. Well, if we could call our constructor, we could just construct a rectangle with arguments side, comma, side. The way we get to the constructor is just this. And that makes a square. So if we construct just a new rect parentheses 5, it actually makes it a 5 by 5. And we could add something else, which is a constructor that takes no arguments, which just makes a 1 by 1. And that would work fine. Or, you know, we could also just do this, just make a square that's got a length of 1 on each side. And now if we construct without arguments, it makes a 1 by 1. So that's the other thing we can do with the keyword this, is we can use it to refer to constructors in the class definition. Eventually we'll see, and we don't need to do this, we could just rewrite the code, right? But if we're doing a lot of things in this constructor that we also want to do for squares or for a default, instead of replicating all that code, we can do whatever we need specifically for a square and then just refer to this default constructor. So those are two common uses for this. Eventually we'll find lots of cases where we actually need to know who we are because we want to pass our identity to another method, possibly in another class, probably in another class. And we're going to use this as an argument to a method. And then the method we call can save, you know, remember the caller equals this, and remember the caller will be the ID of whoever called that method. And that's going to be really useful when we start doing GUIs in particular, because we're going to make lots of different classes running in different processes, and they're going to want to share information back and forth. So we'll come back to this throughout. And it's inherently a painful topic to talk about because it's hard to say more than a few sentences without using the word this. And it's a problem with English. So we'll make up a new word for this. We'll call it a heffalump or something. But all right, so that's the lowdown on this. So I've been seeing this in people's code, and I just want to make sure you understand what it's doing and why it's there, right? So, and I was planning not to talk about it because last time that I talked about this last year, people kind of went crazy with it, and they put this in front of every single variable for the rest of the term. And I could not get it out of people's heads that you don't need to use the word this, right, unless there's an ambiguity. But it was this dot x equals this dot x plus this dot y plus this dot z, right? So I don't want that to happen. But like I say, people are starting to use it anyway. So so I thought I'd go over it. But you know, down here I don't need to say this dot height because height has to mean the class variable. All right. Questions? We got 10 minutes. Let's talk about networks. Let's talk about doing input. No network. All right, we will just fake this. So we're going to talk about a class called scanner. And if you Google Java scanner class, 3 words, first thing that comes up should be the Oracle documentation. And it looks like the Java doc we looked at for string and all these other things. And we can look at that tomorrow. But scanner is a way to read input from something, typically from standard in. All right, so first thing we're going to do is construct a scanner object. So we're going to say scanner, and I'm just going to call it SC for scanner, equals new scanner. And the argument we're going to give specifies what we want to read input from. And to read from standard in, we're going to say system.in. So scanner SC equals new scanner system.in. And then I'm going to say string temp equals sc.nextLine. And this is going to say, let's read a single line from standard in and copy it into this variable called temp, which is a string. And then let's print out the value of temp. And as usual, I'm going to put delimiters around temp so that if it's empty or if it's got a new line or something, it's clear what's going on. And that's our whole test program. 3 lines of executable code. Construct a scanner on system.in. Call the next line method to read 1 line of input. Save it in temp. Print out the value of temp. So this is like a glorified fgets. Now, when I try to compile this, I'm going to get errors saying, I don't know what scanner is. Now, if I say string, or I say double, or I say system.out.println, it knows what I'm talking about, because those things are always defined by default. But scanner is kind of like square root. It's not explicitly defined unless we tell the compiler what scanner is. So if you go to the documentation page for scanner, you'll see something at the very top that says java.util.scanner. And it's in the top like 4 or 5 lines of the documentation. And this is basically saying where we find the scanner class. And it's inside something called Java, and it's inside something underneath Java called UTIL for utilities. So instead of #include, we say import java.utility.scanner. So it's basically telling it where it can find the scanner class. So if we compile that, that compiles fine. And now if we run this, it sits here and it's waiting for a line to be sent through standard in. So I can say this is a test, and it tells me temp equals this is a test. And there's no new line built in, so we don't have to worry about the new line being tacked onto the end like fgets does. And if we just hit an enter, our string is just empty. And if we hit a Control D, we get an exception. Remember, Control D signals end of file. We're asking it to read the next line, so we're in Java util scanner next line, and we got an exception, no such element, no line found. We asked it to read the next line, instead it detected end of file. That's an error. So here's what we would normally do. We would normally say, let's just make temp a string. We call a method in SC called hasNextLine, which says, is there another line available? So if there's another line of input available, let's set temp equal to that. Let's go ahead and print it out. And then let's go back to the top of our while loop. And when we're done, we'll just print a message saying we detected end of file. And like all good things, we should close our scanner because it's doing input from something, and when we're done doing input we should go ahead and close it. So we'll call sc.close. Just to indicate we're done with the scanner. I don't think so, unless I did something I shouldn't have done. So this is fun, hello, there's an empty line, there's a line containing 3 things, and so on. And when I hit end of file with Control D, it says end of file detected, and it exits.
So why isn't it taking temp equals this is fun as the new line and just swapping between the two of them over and over again?
So tell me why it might do that.
So the thought is that while SC has next line is always open, and then temp equals SC next line, and then it prints out, and then it goes back up to next line. So the question is whether or not the system.out counts as the next line, or it doesn't.
So it's consuming input, it's like fgets. When I say sc.nextLine, it's reading whatever is in the input up to the next new line. It's storing that in temp, but now that's gone from the input stream. So the next time I say has next line, it says, is there a line after that one? Right, so it's basically moving through the input. And if nothing's been typed, has next line blocks, it's waiting for something to be typed in, followed by a new line, and then it'll come back and say true. Or if it detects end of file, it'll come back and say false. And if it says true, then next line will return whatever that new stuff was that was typed in. Make sense?
Does scanner class also have a feature for converting
Mm-hmm.
to integers or?
Yep, it does. So we'll do that right now. So standard in, we can redirect because we're in Unix. So if I run my main method and I redirect from main.java, it shows me its source code. Right, so it's just reading from a file. So that's one way to get from a file, is just redirect. So yeah, we can also do things like, well, sc.has next, I don't know if it's int or integer. And I'm going to make temp an int, and I'm going to say temp equals sc.next. I think it's just next int. And I'll print out temp equals, and I'll print out the value of temp. Hey, you got it right. So if I run this and I type in 23, it read in the value 23. If I type in -1, it read in the value -1. If I type in 2.5, well, it wasn't end of file, but has next int returned false because the next thing in the input stream was not an integer, it was a double or a float. So this thing has next int came back and said false, and that kicked me out of my while loop. So you can use this kind of like scan or scanf, right? But again, sometimes it's easiest to use has next line and next line, which is like fgets, read in that entire line and then start processing that to see if it's an integer or a particular string or things like that. But the scanner class is huge, and so look at the documentation. We'll look at it tomorrow online, and it's got lots of methods. Has next int, double float, character, strings, so on and so forth. But if you read in a next line and you've got a string, then you've got all the methods available in string, including regular expression matching, and so we can do lots of parsing. But anyway, that's a way to get you on the air to be able to read in a string, read in integers, things like that, which may help you with debugging because now you can, you know, read in 2 numbers, make a fraction out of it, print it out, call the double method, and so on, and play with it like that. In PA2, this will definitely help, so you don't have to recompile every time you want to change a test case. All right, cool. So we'll play more with this tomorrow, and then we'll segue over to looking at linked lists.